So in this problem, we're going to solve a mean value theorem question. Find all points C that satisfy the mean value theorem for f of x equals x cubed plus 2x squared minus x on the interval -1 to 2. So I wrote the mean value theorem over on the right. It says if a function f is continuous on the closed interval ab, differentiable on the open interval ab, then there's a point C in between those two endpoints such that the derivative at that point is equal to the average slope of the function over that whole interval. So what does that mean? I think it's easiest to see graphically. So let's say that we have a function f of x, and this is a, this is b, and it looks something like this. Alright, so this is continuous on AB and it's differentiable on AB. Alright, so first off, what's the average slope? M bar. Well, to get that, we're going to fill in the endpoints and then draw a line that connects them. That's the average slope. Okay? So the mean value theorem is telling us that there's at least one point, C, in between A and B, such that the tangent line at C is equal to this average slope, or parallel, right? So for this function, we would have 2 points, right? Here, tangent line looks like that, and here, tangent line looks like that. These tangents are both equal to the average slope. So there's 2 points where the tangent equals the average slope. Alright? So let's check that this function satisfies the mean value theorem. So it's a polynomial, so it's definitely continuous on -1, 2. And it's definitely differentiable on -1, 2. Oops. Okay, so we know that there's going to be at least one point C where the derivative of this function equals the average slope of this function on -1, 2. So let's find out what that average slope is, M bar. That's going to be, right, so f of 2 minus f of -1 over 2 minus -1. That's how we find the average slope. So that's going to be 2 cubed plus 2 times 2 squared minus 2 minus -1 plus 2 plus 1 all over 3. That's going to be 8 plus 8 minus 2, so 14. And then it's going to be minus 2, so that's going to be 12 over 3. And that's 4. Okay, so M bar, the average slope of f on this interval, is equal to 4. Alright, we're going to have to use this later. So now we need to find f prime, right? We're trying to find point C so that f prime of C is equal to M bar. We need to get f prime. So the derivative, we use the power rule. It's 3x squared plus 4x minus 1. And then we need f prime of C, which is 3c squared plus 4c minus 1. That has to equal 4, the average slope. Okay, so this is solving a quadratic equation, right? So 3c squared plus 4c minus 5 equals 0. So it's going to be - plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So that's negative 4 plus or minus. Okay, so we got 16. Negative signs turn to a plus. That's going to be plus 60, so plus or minus square root of 76 divided by 2 times 3. That's going to be negative 4 plus or minus. So this is going to be square root of 4 times 19 divided by 2 times 3. So I can pull a 4 out. Negative 4 plus or minus 2 root 19 divided by 2 times 3. And I can pull a 2 out of the top. Negative 2 plus or minus root 19 divided by 3. So I pulled out a 2, and then I canceled the 2 on the bottom with the 2 on the top. And so if we took the negative portion, it would be negative 2 minus root 19 over 3. Root 19 is larger than 4 because 4 squared is 16. So this is going to be more negative. It's going to be like negative 2 minus 4.2, right? Which is going to be larger than negative 6. And negative 6 over 3 is going to be negative 2. So that root would be to the left of our interval. It's not going to be in our interval. So we're going to take the positive root. And it's going to be negative 2 plus root 19 over 3. So this is C. C is negative 2 plus root 19 over 3. And so this is a lot more algebra than usual. Usually the problem works out to give you a number like 4 or 0, not negative 2 plus root 19 over 3, but the main idea is that you're going to find points so that the derivative at those points matches the average slope of your function on the interval. Just think of this picture to remember the mean value theorem. Draw a line, and then connect the 2 endpoints, and then there will be points in between the endpoints where the tangent line is parallel to that average slope. And then to do that algebraically, you can calculate the average slope, calculate the derivative, set them equal to each other, and then see what points are possible.